Hi everyone. In today's lesson we will be studying the binomial distribution in probability, which is a topic in each IB Math program, IB Math AA and AI, standard level and high level. We will learn what the binomial distribution is and the conditions needed to apply it, and of course we will do a full example on it to understand it very well and apply it correctly, so that hopefully by the end of this video you will be very confident about the binomial distribution. And of course we'll show how to solve these using the GDC in a moment. So first, the binomial distribution is a discrete probability distribution that needs two parameters, n, which is the total number of trials, and p, the probability of success. Here, in this distribution, the random variable x takes all the values from 0 to n. We'll clarify these in this example. And also here, you need to know these four conditions to apply the binomial distribution very well. But to understand them better, I will explain them at the end of the video after this example. It will be much easier to understand them after this example. So now, here as you see, we have a question. A multiple choice test of 20 questions in total. Each one of them has 4 options or 4 choices. Let's say A, B, C, and D. Only one option or one choice would be correct. Sam answers every question by guessing completely at random. Now, why they said this sentence is very important, and it's related to these conditions, as we'll explain later. In this question, we need to find the probability that Sam answers exactly 5 questions correctly. So to do the entire question here, first we will define a random variable x that represents the number of the questions done correctly. So here x belongs to binomial distribution. Here n will be the total number of trials, which is here the total number of questions, 20. Now the probability of success is the probability of having one success in one single trial, which is here solving the probability of solving one question correctly. Now here guess, you have 4 options in each question, A, B, C, and D, for example. What's the probability that you will choose the correct one out of these 4 if you are choosing at random? Of course it will be 1 out of 4 or 0.25. This will be our probability of success. Here the values that x can take will be 0, 1, 2, up to n, as you see, which is here 20. So for example, when Sam solves 0 questions correctly, like all of them are wrong, then it will be 0 questions correctly. If one question is done correctly only, then x will be 1. If all of them are done correctly, then x will be 20. And of course we cannot have more than 20 here because all of them are 20. We need to find the probability of solving exactly 5 questions correctly here. So x equals 5, exactly 5. When we have equal, we use what we call in calculator binomial PDF, as we'll see here, which stands for binomial probability density function. First we add calculator, then we go to menu, number 5 probability, and then distributions. We choose binomial PDF, which is the last one, as you see here. The calculator will ask you about number of trials, which is here in our case 20. Then the probability of success, as we saw, 0.25. So here 25. The x value, as we see, 5. So we write 5, and then as you see the answer will be 0.202 to 3 significant figures. Now in B, find the probability that Sam answers at least 3 questions correctly. So here we have an inequality. At least 3, which means 3 or more. Now here, when we say 3 or more, it means minimum 3. So it could be 3 or 4 or 5, all the way up to 20, because we have 20 questions maximum. So when we have inequalities, we use binomial CDF, which stands for cumulative distribution function. So here we scroll down, as you see, binomial CDF. You choose PDF again. So here binomial CDF. Now here number of trials 20, probability of success 0.25, and here we have, as you see, lower and upper bounds. So this is always the case when we have binomial CDF. Here, since we need to solve 3 questions as minimum, like 3 or more, the lower bound will be 3. Since we don't have an upper bound specified here, so it will be the largest number in our case, which is 20. Solving at least 3, so 3 up to 20. Here we'll get, as you see, 909 when rounded to 3 significant figures. Now, here we need to be careful about inequalities and the bounds. Here find the probability of solving 7 questions or less correctly. So it could be 7 as maximum or upper bound, or 6 or 5 or 4, all the way up to 0, which is the lowest value, or it will be here the lower bound. So we'll use now binomial CDF again. Number of trials 20, probability will be 0.25. Here, since they don't specify a lower bound, it will be the very lowest, which is always 0, and the upper bound at most 7 questions correctly. Here we can say this at most 7 questions correctly, or 7 or less. So here we have 898, so 0.898, done. The next one, as you see here, we have only more than 9 questions correctly. More than 9, not 9 itself, which means a minimum of 10 questions correctly. So a minimum of 10, the lower bound will be 10, not 9. Since we don't have an upper bound stated, it will be the very largest one, which is 20. This is, by the way, equivalent to saying that x bigger than or equal to 10. So the lower bound will be 10. You can copy this and paste, but I'll just do it. Then here 20, and we have 0. Then the lower bound, as we said, 10, not 9, but the upper bound will be 20. Then, as you see, 139. When rounded, it will be 0.139. Oh, no, I see 0.0139, which is, as you see, very unlikely. It's nearly 1%. Now here, the probability of x between 3 and 12, but more than 3, not including 3 itself, but including 12, like solving more than 3 questions correctly, more than 3, so a minimum of 4, but a maximum of 12 itself. So here, keep in mind the lower bound will not be 3, it will be 4, because 3 is not included, but the upper bound will be 12 as written, because 12 is included. So we do here CDF also 20, 0.25. The lower bound will be 4, then 12, as you see, 0.775. Now next here we have find the expected number of questions solved correctly. Here the expected number of questions, not a probability. So here we call it the expected value in the binomial distribution. It's given in the formula booklet like this: n multiplied by p. N will be the number of trials and p the probability of success. In our example, n will be 20 multiplied by p, which is 0.25, and that will be at the end 5 questions here, which is really logical. You have 20 questions in total, and with a probability of 25% to solve each one. So that's why you would be able to solve 25% of the total questions, 20, and that will be 5 questions. Now, after we did this example, we'll explain these. They will be now very clear. In any binomial distribution, first, you must have a fixed number of trials, n. So here we have a total number of 20 questions. It's fixed. They don't increase or decrease. Next, each trial would be only success or failure. So in our case, each question would be solved correctly or not correctly. We don't have a third option. In the coin example, it would be either head or not head, which is tail. In the dice, could be either getting 5 or not 5. As you see, only success or failure. Then you have a constant probability of success P. So here, the probability of solving each question correctly should be only 0.25, not more or less. It doesn't change through the question. Like, for example, you don't have questions with a probability of 70% correctly, other questions that are hard, let's say 0.10 or 10% correctly. In this case, the binomial distribution will not be valid if each question has its own probability. Like, this question is easy, so it has a higher probability of success. No, this is not valid. That's why here we said guesses the questions completely at random, so that all of the questions have the same probability of being done correctly, 0.25. Then all the trials must be independent, which means in our case, for example, if Sam solves question 1 correctly, let's say, that doesn't mean necessarily question 2 will be also correctly. It's not related to question 1. Even if 1 is done correctly, question 2 could be done correctly or incorrectly. It's not related to 1. They are independent. So this is what we mean by independent trials. I hope that you have found this explanation helpful. Please hit the like button and consider subscribing. Thank you for watching.